Hello everyone and welcome back to my channel. So from this video, we are going to discuss how to do various VectorDB operations using free and open source vector database, which is Meta's Faiss DB. So this VectorDB is mainly popular for efficient similarity search. So compared to other vector databases such as ChromaDB, this is so efficient, especially when you are dealing with a lot of documents. And basically with this video, we are going to discuss operations such as how to initiate VectorDB, how to do similarity search, QnA, and save and load VectorDB from the disk so that we don't need to initiate it again and again, and also to view the documents in the VectorDB as well as deleting the documents in VectorDB as well as add additional documents to the VectorDB. So I also want to mention, like, if you have not subscribed me, please go ahead and subscribe so you can see more of these kind of videos. So without much talking, let's move to our notebook. All right, so this is the code, the notebook of today's video. So initially, what we need to do is install the libraries. So here we need to install Faiss CPU. So that's the library that we will be using for our vector database. And then again, we need to install OpenAI and Langchain and PyPDF as well as a TikTok. So this one, again, I'm using with OpenAI. But you can use it with other language models as well. So and next we need to import the libraries. So here I'm importing the library various components from the Langchain, embedding constructors and splitters, and from the Langchain vector stores I'm importing the Faiss DB. So in our previous videos, mostly we use the ChromaDB. In this case, we will be using the Faiss DB. And next, we need the document loaders, and then OpenAI and VectorDB QA. And this one is the retrieval QA with sources. So you can use it either chains with sources or without sources. So here I'm using with sources so that I can see where the data is coming from. And also here we are using Pandas library. So this is basically to visualize in better way what we have in our vector database. And next we have to set our OpenAI API key. So if you're using other language models, you can use those corresponding API keys, or otherwise you can use the open source ones. All right. So the first task is to upload the documents and vectorize so that we can use these in our VectorDB instance. So here I'm using the directory loader, and then I am giving directory path in my Google Drive. So this path contains several files that I have. So I have created with the ChatGPT. I have one document regarding Australia, and again regarding India, and I think again another one regarding USA. So I'm basically have located all of these PDF files in my Google Drive in this location. So from this, I am simply loading them, and then I am getting all the pages, and then I am doing the splitting, and finally I am creating the document chunks. All right, so next I'm initiating the OpenAI embedding constructor so that we need to we can use it for our vectorization purpose. So simply initiating the Faiss DB is super easy. Basically, we have to call this line. So the Faiss dot from documents, and then we can give the documents. Here we construct it, and then we can give the embedding extractor. So basically with this, it will construct the vector database. So let's try out this in various tasks. So the first one is similarity search. So in the similarity search, basically, we are trying to get the vector distance. So basically in our vector database, we have all our documents as numeric representations. So given a query, we will convert it into another numeric representation, and then we get the distance between these vectors, and we will list the most similar documents to the corresponding given query. So that's what basically happens with the similarity search. So for instance, here I am giving the query as Australia, just a single word, and then I am trying to get what are the most matching documents to this given query. So we can do that by db.similarity search function. And here I'm given the Australia. So as I mentioned, I have a document which contains details about Australia. So this document contains 3 pages. So as I'm chunking with the pages, what I'm getting is all the 3 pages of the document which has information about the Australia. So this is the first one, the most matching one is the page 0 of the Australia document. And next I have this one. Again, this is the page 1. And again, I am getting, all right, so next I am getting the 3rd page of the same document. Yeah, page index 2, which is the 3rd page of the document. And then only I am getting the my other document, which is the single page document regarding the USA. So like for the given user query Australia, it seems it has correctly identified that, and it gives all 3 pages of the document Australia, and then only it has moved to the this USA document. So here in this case, it gives in default 4 documents, and first 3 documents are from Australia, and the last one is the USA document. So we can see that this similarity search method is again working very well. So you can also try out with your various use cases. So that's how we can do the similarity search. All right, so moving forward, next I will move to the next task we are going to do with our Faiss DB. So the next one is QnA. So this is something pretty much familiar with us. So basically here I am creating a QnA model using the Langchain retrieval QnA with sources chain. And then I am simply giving, so I'm creating the retriever instance using our Faiss DB. And then I'm giving it as the retriever. So then basically we can do QnA. So as I mentioned, I have a document regarding India. So from here I'm asking question, what is the population of India? Then it gives the correct answer. The population of India is over 1.3 billion people, and also it gives the source correctly. All right, so that's how we can do QnA. So I think I don't need to talk much about this thing, because we have used this pretty much in our other videos. All right, moving forward to the next operation. Next, I'm talking about how we can save and load this vector database. So basically here we are saving this constructed vector database in our Google Drive. So if you're using this code in locally, you can save it in your local disk. So basically this is important so that you don't need to construct your vector database again and again. So once you have selected these are the documents that need to be in vector database, you can create the VectorDB and then you can save it. So the next time you're using it, basically you can load the constructed DB from the disk itself. So the saving is super easy with Faiss DB. Basically you need to set the directory where you need to save your vector database. So here I'm giving it as store. And next, you have to call db.saveLocal method call. So with this, basically, it will construct a folder called store, and it will save the vector database. So let's run this. Okay, so it has completed the task. So if you open up the files from the Google Drive, here you can say there is a new folder, and if you expand this, inside this you have these 2 files which contain the various vectors we have in our vector database. So we have the Faiss file as well as the pickle file. So both of these files represent our vector database. All right, so as we have saved it our drive, so we can again load it back to our notebook. So here for that you need to use Faiss.load module and then give the save directory, which is the store, this one. And then again, we need to provide the embeddings that we use to construct this DB as well. So with that, I'm loading it to a new variable called new DB. So I will run this. All right, so in that way, we can load it back to the notebook. Okay, next I am talking about how to view the documents in vector store. So this is again important because once we have constructed a vector database, we should be able to see what we have in this vector database. So here we are using Python pandas library to beautifully visualize the vector DB we have. So here I have two functions here. The first one is to show vector store. So for this one, I need a vector store object. And then basically, given the vector store object, vector database object, basically I am converting it to a data frame. Then I am visualizing the data frame. So the converting the vector store into a data frame is done by this function. So basically in this function, I am calling the doc store of the vector store, and then I'm converting it to a dictionary, and then I'm iterating through it, and then I'm extracting the Faiss index ID, as well as it has two types of data, the source, the page content, as well as the metadata. So the page content basically contain the text content in the pages, and in the metadata we have the source. The source is the PDF name, file name, and then we have the page. Page is basically the page of the corresponding document. So with this function, basically I am iterating through each of these Faiss index IDs, and then I'm extracting each of those details. Basically, I'm getting the content, document, and the page. So the page is with the Python indexing, which starts with the 0. So for the convenience, I'm adding 1 to it so that we can start paging from the 1. So that's what basically this function do. And next, if you call the show vector store, and so here I have loaded back the Faiss DB from the our local disk, our Google Drive. So I'm going to visualize this newly loaded vector DB. So if you run this, you can simply get this as the output. So here basically you have the chunk ID. So this is the ID of our Faiss chunk. So here we have in several rows, we have the chunks of our documents. And this is the chunk ID, and this is the corresponding document. And then this is the page, which page this document chunk belongs to. And this is the content of that particular chunk. So here you can see I have three different documents, India, USA, and Australia. And the document Australia has 3 pages here. So each of these pages are different chunks, and each of these chunks again has corresponding unique chunk IDs. So that's all we need to see from our vector database. So I have masked the irrelevant information from here. So if you again click on this button, you can see the details. All right, run this again. Yeah, if you click on this, right, so you can see the content of each of the chunk more clearly with this expanded view. So in this way, we can visualize, we can interpret our vector database. All right, next I'm going to talk about how to delete documents from the vector store. So once we have created the vector database, sometimes we come across documents that should not be there. So sometimes we change our mind and we need to delete documents from our VectorDB. So this is again possible with a little bit of trick. So here I have created these two functions. Basically, after deleting a document, we need to refresh our model because we are using this constructed model to QnA, similarity search, and etc. So in that case, if we are doing a QnA kind of thing, we need to do the refresh of modeling as well. So basically in delete document function, we need to give a vector database, vector store, and then the document. So this document is the document we are going to delete. So in order to decide which document we need to delete, again, this visualization function is again useful. So, all right. Right. So here also the first task is to converting the vector database into a vector data frame. So for this again, I'm using the previously defined function. So previously we defined this function. So again, I'm using this. And then after converting it to a data frame, next I need to get all the IDs of the file that I am planning to delete. So for instance, if we are trying to delete this australia.pdf file, so this file contains 3 chunks. So if we need to delete this document in the vector store, we need to delete all 3 of these chunks. That is the only way we can get rid of this document from our entire vector database. So for instance, if we are deleting this india.pdf, we only have 1 chunk, but again, we need to know which chunk ID that is corresponding to. So in this line of code, basically what I'm doing is I am getting all the chunk IDs which are mapping with the given document ID, and then I'm creating a list of that. Next, I'm calling the store.delete method call, and then I'm forwarding this chunk list. So with this, basically, it will delete all the chunks that correspond to mentioned document. And next, if you are doing the QnA, again, we need to refresh this model. So here, basically with this, I'm creating a new retriever and forwarding it to the model retriever QA with sources chain, and then I am emitting the model back. So with this, basically, I am refreshing our QnA model. All right, so that's how we can define these two functions. And then, for instance, here I am going to delete the document australia.pdf. So if I'm running this, right, so this will basically delete the australia.pdf. So here, previously when we are showing the vector store, we saw there were like 5 documents, there were 4 documents, and India, USA, and 3 chunks for the Australia. So now I have deleted the australia.pdf. So this should ideally delete all the chunks related to Australia. So let's run this and see what we have now. All right, so now we have only 2 documents, India and USA. So this has successfully deleted all the chunks which mapping with the australia.pdf. So, and again, let's do some Q&A as well. So here I'm refreshing our model because the model is need to be updated as we have updated our vector store. So here I'm asking question about Australia, and this is the answer I'm getting. I don't know because this information is no longer available in the vector store. So it says I don't know as the answer. All right, so that is the expected behavior. So because we have deleted Australia document from our vector store, that information is no longer available. So with Langchain, there is some tendency to pick the online sources from Google. So there is some kind of an error in the Langchain. So sometimes if we are trying to ask questions from the data which is not available in our vector store, sometimes it's trying to fabricate the links and try to give answers. So this kind of behavior can be happen in this kind of scenario where we asking questions from the we asking questions where the corresponding data is not available in our vector store. So that is something we have to pay a little bit of attention when we are using these large language models, because these are probabilistic models and it tries to come up with the fabricated data based on the word probabilities. So that is one thing to keep remember while doing while deleting the sources and try to ask questions from those deleted sources. All right, so that's how basically we can delete a document from our vector store. Next, let's talk about how we can add new documents to the vector store. So currently we have only 2 documents left. We have deleted the Australia, so we have India and USA currently. So from this, let's add more documents to our vector store. So basically for this, I'm using the merge operation from the Faiss. So here again, we can do the same thing. So this function basically takes 2 parameters. The first one is the directory. So this directory should contain the new documents that we are willing to add to our vector store. And next we have to give our current vector store, because this vector store will be extended with the newly adding documents. So again, we can run the directory loader, which will load all the documents in our new directory. And then we can chunk the pages and do the text splitting and construct the documents. And then what we need to do is we can call files from documents and then do the documents as well as embeddings, and then create a temporary vector store. So this is the extension is the temporary vector store. Next, what we need to do is we need to merge this temporary vector store with our original store. So you can do it with store.merge from extension. So basically with this, all the documents given in the directory will be added to a vector store, a temporary vector store called extension, and then it will be merged with our original vector database. So here I am adding new documents. So in our this folder, I have a new document called Canada, which contains information about the Canada. And then with this, if I run this, so I think I have run this as well. All right, next I will call this. So basically this should ideally add the new document Canada to our existing vector database. So here I am giving the new directory which contain my new documents, and then I'm giving my existing vector database. So if I run this, this should add a new document to our vector store, and then I will again run the visualization code so that I can see what's available in the extended vector store. So if I'm running this, right, so the new document, the Canada.pdf, is again available in our vector store. So that's how we can add new documents to our existing vector database. Again, we can refresh the model because we have updated our vector store. We need to refresh our QnA model. So here I'm asking question, give description about Canada, and here it gives the correct answer with the correct sources. All right, so that's it from this video. So basically from this video, we have discussed multiple operations that we can do with Faiss DB. So basically we initiated Faiss DB, and then we did a similarity search, and also we did QnA, and then we discussed about how to do save and loading Faiss DB, and then we discussed how we can view the documents or the content in our vector database. Afterwards, we discussed about how to delete documents from vector store. as well as add new documents to the vector store. So that's it from this video, and thank you for watching. And I'm inviting you to subscribe my channel and like and share my videos with your colleagues. And thank you so much. See you from another video.